Hello, Algebra 1 friends. We are working on section 3.1. We're going to be writing equations. Our vocabulary today consists of four phrases, or actually three phrases: four-step problem solving plan, defining a variable, and formula. So those four steps are as follows. The first thing you want to do is read and explore the problem. Make sure you understand exactly what you're being asked to do in the problem. Make sure you collect your information. Make sure you know the information you have and definitely the information you're looking for. The next thing you want to do is set up a plan. Try to figure out a way to solve for that missing information. Sometimes it will require you writing an equation or even defining a variable. Defining a variable is something we'll talk a little bit more about in a few minutes, but defining a variable is a really important step because it helps you isolate what is important, what is the thing you're looking for. The next step that I would recommend is to solve the problem. So you've set up the information, you set up a plan, you've defined a variable, maybe even set up an equation. Solve that equation. See if you can use and apply the mathematical rules that we've been working on so far to help you learn how to solve equations effectively and correctly. And the next thing you want to do is examine the solution. I think that's kind of a funny way of putting check your answer. Check that your answer makes sense. You want to examine if it meets the if it actually answers the question. The worst thing is when a mathematician like us, we sit down, we work really hard, we stumble, we work through a problem, and then we finally get to the answer, and then you look at the answer and you're like, this doesn't really even make any sense given the problem that I'm starting off with, right? So you need to make sure that after you've done all the first three steps, you make sure that your answer makes sense for the situation. So defining a variable, let's discuss that. Really what that would be is creating a variable or choosing a variable for one or more of the unknowns in your situation. Though this statement is not really a problem, it is a statement that we can think about defining a variable. So my eldest child is 10 years older than my youngest. Pretty simple. You guys can kind of figure out what that means. And so if I were to talk about the two people in this situation, my eldest child and my youngest child, I might want to put some variables in the situation to refer to them. So let's let E be what? Now, this is the thing that most students get kind of wrong, or this is how we get confused. When you define a variable, you must say something that refers to a numerical value. I can't say E is the eldest child because that would mean that his name is E, and that's just not accurate, okay? So what you need to do is make sure that when you have a variable and you're defining it, you define it with a numerical amount. So E is the age of my eldest child is an appropriate way to define a variable. So that's pretty decent, though later on in math we will never use E as a variable because it actually has a value, but we can play around with that right now. And the other variable I could use is Y, and Y could be not my youngest child, but is the age of my youngest child. So with those two variables defined clearly and obviously referring to a numerical value, I can actually go on to write a formula for this relationship. So a formula is how variables relate to one another. So a formula is a mathematical sentence that shows the relationship between two or more variables. So what am I talking about? So you guys have all heard E equals MC squared and A squared plus B squared equals C squared. These are like common, I call them television equations that you'll see on the board if people are doing math. And sometimes you might see this one and you're going to get to these and what would it be? X is equal to negative B plus or minus the square root of B squared minus 4AC over 2a. All of these are just formulas. They're a sentence that relates the values of different variables. This one would be E, M, and C. This is A, B, and C. And this is X and B and A and C. So all of these are just formulas. I'm going to write a formula for this situation. Watch. So I know my youngest, and let's say we're going to use Y for the youngest. My youngest would be equal to the eldest, but they're 10 years apart. So the youngest is equal to the eldest minus 10. So this is one way to write the relationship between those two children. and to write it as a formula. So anytime I'm given the age of one person, I could easily calculate the age of another person. All right, thank you guys for letting me go through that chatty discussion. Let's go ahead and look at some examples. So in this first example, we're going to be translating each sentence into an equation. Knowing that we're going to be translating it into an equation, I'm going to put an equal sign down because an equation must have an equal sign. So the next thing, let me get my error message out of here. The next thing we need to do is figure out what's on both sides. And the word is a really good breaking point to tell me that if something is something else, that means something equals something else. So now that is helps me break down my situation, and I'm going to figure out what's on either side of my equal sign. So let's take a look. 5 times the number A is equal to 3 times the sum of B and C. Well, let me get this part down. 5 times the number A. We know that that would be 5 multiplied times A. But in math, I don't have to actually, especially in algebra, I can write a coefficient and a variable side by side, and we know that means multiplication. So 5A equals 3 times something, 3 times the sum, 3 times this thing, the sum of B and C. Sum we know means to add, so 3 times B plus C, that's the sum, and now we're going to multiply it times 3. And this is the equation we came up with from that sentence. Let's take a look at this next part. Part B says 9 times y subtracted from 95 equals 37. I'm writing an equation. I'm going to put my equal sign, and this particularly verbal or explicitly written equation has the word equals in it. So I can literally just plop that down and I know where the break is. So 9 times y subtracted from 95 is equal to 37. Well, something equals 37. Let me put that down. This is a little tricky for me because in my mind, I'm going to kind of do a thought bubble. Bloop, 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 bloop. In my mind, I'm like 9y minus 95. But like I'm reading it and it doesn't feel right. So I'm thinking about this, but I'm not sure. 9 times y, got it, subtracted from 95. Wait a minute. This isn't 95 being taken away from 9y. This is 95 then subtracting 9y. Read it again. 9 times y subtracted from. You have to be careful with these because they can be tricky. And that one I found a little tricky. So I'm going to put 95 first, even though it comes later in my sentence, minus 9y. So here are the 4-step problem solving plan. If you want to take a screenshot of the way they have it in the textbook, now would be a great time. Example 2 uses some information from this sidebar. It says that the first ice cream plant was established in 1851 by Jacob Fussell. Today, 2 million gallons of ice cream are produced in the United States each day. Now here's for our problem. Use the information at the left, which I just read. In how many days can 40 million gallons of ice cream be produced in the United States? If you need to pause me, make sure you understand all the details of the problem. That's that first step where we're kind of exploring the problem. Then we're going to think about how we would plan the solution. So after you've taken a look, pause me, do that. We'll get back together and let's talk about how we can do it. So we know that the rate is 2 million per day. Let's see how many zeros that is. That's 6 zeros. So 2 million per day. And we know that if it's 3 days, then that would be 2 million times 3 if it's 4 days, but we don't know the number of days. So I'm going to, it says how many days. So I'm going to multiply by D, but I shouldn't write that D down until I've defined it. D is the number of days needed to produce 40 million gallons of ice cream. So now that my D is defined, I can happily put it in that equation so I can work this situation out. So I want this number, when I multiply 2 million times D, to equal 40 million. And let me write that 40 million out completely. Okay, and so we know how to solve problems like this. We want to isolate this variable D. We're going to divide both sides by 2 million. And when I do that, well, you guys remember you can cancel out zeros at the end as long as you're doing the same number. You guys remember that, right? So really this becomes 40 divided by 2, which is just 20. So it would take 20 days for this situation to occur, for 40 million gallons of ice cream to be produced. And it makes pretty much good sense. If I read the problem again, when I kind of examine my solution, it makes sense. So I'm feeling pretty confident about it. So in example 3, we're going to have an opportunity to write a formula. We're going to translate the sentence into a formula. Now listen, the perimeter of a rectangle equals 2 times the length plus 2 times the width. So we know that we're talking about a couple things. We've got perimeter, that's going to be one variable of a rectangle is equal to 2 times the length. That's another variable, and then 2 times the width. Now, you guys have seen this formula tons of times, so this is no surprise, but if you think about it, we would need to define the variable. So I'm going to do that quickly. So I have that P is the length of the perimeter, which obviously deals with a number or is referring to a number. L is the length of the length. I know that sounds a little off, but you know what I'm talking about. And W is the length of the width. So now that I've got these variables defined, now I can relate them together. It says the perimeter of a rectangle equals. So already I've got my P, and that's going to equal something. What does it equal? It equals 2 times the length plus 2 times the width. And we know that to be 2L plus 2W. And here we go. We've written a formula that we can use anytime we have any parts of this information to, infer the other. These types of problems are kind of fun sometimes, and sometimes they're a little bit tedious. But basically what we're going to be doing in example 4 is we're going to translate each equation into a verbal sentence. So we've got 3m plus 5 is equal to 14. And honestly, you could write that 3m plus 5 is equal to 14. Or you could be a little bit more creative. So a possible solution could be 14 is equal to the sum of 3 times m and 5. So we're talking about the sum of two numbers, that's 3 times m and 5, and is equal to, we see that equal sign there, and we've got 14 on the other side. Let's try the next one. So for this one I wrote, the sum of v and w is the same as y squared. And so what you notice is that this time I didn't write equal to, I said is the same as, which we know actually can be translated when we're dealing with algebra as that equal sign. And you notice on either side of the equal sign, we have the same two different phrases that we know are equal to one another. Here in example 5, our final example, we're going to write a problem based on some information given. Here we're given that A is defined as Raphael's age, and A plus 5 is defined as Tara's age. Then we have this relationship here. A plus 2 times the quantity of A plus 5 is equal to 46. So how can we write this into some kind of a problem? Well, recognize that the A represents Raphael's age, and A plus 5 represents Tara's age. So it's clear to me that the sum of Raphael's age plus 2 times this Tara's age is going to be equal to 46. Let me write that down. So I've worked this out to say the sum of Raphael's age and twice Tiara's age is 46. All right, guys, I hope that this was helpful. Let me know if you have any questions, and I look forward to talking to you all soon. Take care.